Welcome to our first module covering the basics of visualization design. This module will consist of 5 lessons. First, starting with understanding just what are the basic parts and pieces of a visualization, then introducing Altair, which is going to be the Python-based toolkit that we are going to use for building visualizations in this course. We'll move from there to talking about basic concepts behind visual mapping. How do we actually choose the most effective way to turn our data into visual information? Covering some fundamentals of ethical visualization choices. How do we present our data as honestly and faithfully as possible? And closing with an overview of interaction. One of the beauties of using visualization is it allows us to interact with and explore our data based on our evolving queries and understandings of a data set. So we'll cover some of the fundamental techniques about how to do so effectively. Today will be our first lesson on anatomy of visualization. So the basic idea here is what are the parts and pieces we need to consider when we're designing a visualization, and how do we establish a common lexicon for understanding and talking about what those pieces really are. So we're going to start off with today's lecture talking about why do we actually want to use visualization? What are the benefits of taking our data out of the data file and actually making it something that people can see? Visualization is a particularly powerful tool, but as you might have already guessed, it has a very different set of predictive powers than many of our conventional statistical techniques. And so today we're going to unpack some of the reasons why you should or should not visualize your data. In particular, in the context of this course, we're going to be talking about visualization in the form of information visualization. And information visualizations specifically focus on providing visual representations of abstract data. Think of these as measures without space. These aren't necessarily measures that make more sense when they're embedded on a molecular surface or in some sort of predefined spatial structure, but rather they're measures that exist agnostic of their structure. Think about things like our ratings of efficient movies or the number of cases of a disease. These are measures that have different spaces potentially associated with them, but they make sense and they can be used outside of the context of those spaces. So this is things like pie charts, bar charts, scatter plots. We'll see an entire range of different representational choices that you can make through data when it's expressed abstractly. And the core value behind information visualizations are that they enable people to interpret data sets visually. We can take advantage of the fact that our visual system has evolved over hundreds of thousands of years to really try to understand what are the patterns that exist in their data and how do we communicate them effectively and how do we explore them in ways that allow people to apply their own prior understanding and specific expertise. When we're thinking about visualizations, they represent data using what we call marks. So marks encode attributes of each data point. I can think of a dot in a scatter plot or a bar in a bar chart. Each of these visual units of representation refers to a mark. So visualizations can be quite efficient. They can be very beautiful, easy to interpret, easy to read, concise ways of representing data. However, we've all also seen those visualizations that probably do more harm than good. They might make a data set look very complicated, but they really don't tell us much about what's actually going on in the data. So I want to start by asking you to pause the video for a moment and brainstorm different reasons why we should visualize data. So we have several reasons that we might choose to visualize data. For example, we might want to see the structures and the patterns that emerge when we actually try to explore our data. We might want to see what those patterns are that we know are there, but that are too hard to read from a table. There might simply be too much data to try to make sense of, and we can't actually read each individual value out of our data. Statistics may not actually be enough or maybe too complex to really understand what is going on in our data sets. We have to know the patterns that we're looking for in order to apply statistics effectively. We can also often use visualizations to tell a story using data. Visual storytelling is a tradition that has been around for hundreds of years across every culture. And we can use some of those same traditions to understand how we might effectively communicate through data. Visualization also allows us to explore unfamiliar data. If we don't know what we expect to see, we can start to search through and represent data in different ways to make different kinds of patterns pop out. The alternative to that is we can also use visualization to answer a question. Some questions and queries that we might have in our data aren't easy to answer statistically. So we can use visual representations to really try and make those statistics pop. And I'm going to show you just a couple of quick examples to illustrate the power of visualization for data science and data analytics. So here I have a grid of values, and I want you to pause the video for a moment to see if you can't see any structures emerge in this grid of values. All right, I would be willing to guess that maybe a few of you have figured out the trick that I've hidden in here. But if I map each of these numbers in my table to a color, I might be able to see other kinds of patterns pop out. So I might be able to see that the pattern of ones here forms a smiley face. This is kind of a simple, somewhat facetious example, but in reality, there are more complex phenomena that emerge in the real world that show the power of understanding these structures. Take, for example, these 4 data sets. Would you say that these distributions are quite similar? Many of you have probably guessed that I'm messing with you a little bit here. So all of these data sets have the same first order statistics. They have the same mean, variance, correlation, and regression. But when we actually plot these data sets out, what we can see is that these data sets have qualitatively very different structures. In the upper left, we have kind of a scattered distribution that generally follows a linear trend. In the upper right, we see a distribution that generally has a constant x value with the exception of one outlier. We see a parabolic structure in the lower left, and we see more of a nice linear structure, again with a single outlier in the lower right. So what we can see here is that qualitatively, these data sets have very different properties, but if we were to just look at their first order statistics, we wouldn't be able to see or to characterize these differences. And that's because visualizations really let us see patterns in abstract data. When we're considering how effective a visualization might be, or we're trying to break down what a visualization is trying to tell us, we can do so starting with 3 core questions: the what, the why, and the how. The what refers to what data does the user see? What are the inputs that have created the visualization, and how has this data been processed to show us the kinds of information we want to see? A lot of times when we see visualizations in the popular media, we see things like raw numeric scores, but oftentimes we'll also often see the outputs of models, which actually are more rich than any one data point. They involve a certain amount of prediction and uncertainty and combining of different data attributes to actually make a meaningful prediction and produce meaningful data about a complex phenomena. Why corresponds to why would someone want to use the tool? What is the goal of the visualization? What is it trying to tell us? What questions are we supposed to be able to answer through looking at the visualization? Are we supposed to find trends? Are we supposed to assess outliers? Are we supposed to understand averages? Another aspect of why is, why did the designer choose to show this information? Are they trying to tell a story with the data? Are they trying to facilitate exploration? What is the broader goal of creating this visualization in developing knowledge? And finally, for how, we might look at how has the visualization itself been designed? What visual representations have been used? What interactions have been used? Basically, how has our data been translated into the visual? And what kinds of control or agency have we as the users been given over changing the way that visual representation is conducted? I'm going to walk through a quick example of how we can apply these questions in the context of a visualization of US smartphone market share. So this is a replication of a visualization from the 2000s that looked at and tried to communicate what are the various market shares that different companies have in the US smartphone market. So for our what data is being shown, here we're just seeing a simple volume measure. What is each company's share of the current market? Why is this data being presented? Well, in this context, the data was being presented to communicate these different market shares with stakeholders, and it was being used in the context of a specific company. Then when we think about the how has that visualization been designed? Well, it's been designed using a 3D pie chart to show relative proportion. The theory here is that we have a whole, that's this 100%, the full circle, and we want to see how much does each company contribute to that whole. Well, one of the interesting pieces here is that while these 3D representations can be very engaging, they're also notoriously misleading. So here, by adding this additional false perspective, by making our visualization look 3D, we've actually exaggerated the size of perceived market share. So things on the bottom of our pie chart actually will appear closer to us and larger than things on the top. And because of the way 2D monitors work, this actually causes people to misunderstand what's going on with their data. So in this case, by understanding the how, we might understand that we're exaggerating the market share of the orange, green, and blue slices, which are perceived as closest to us. And we can actually turn around and redesign these representations using other design techniques. So for example, here on the top is the same visualization, just with the 3D removed to support a little bit more accurate comparison. Or we can even say, hey, what we actually care about is not what proportion of the market share each company has, but rather how big are different companies' proportions with respect to each other. We might actually just care about making the direct comparison between companies. And in that case, we might choose to use a bar chart where we can more directly compare the individual links of each of our bars. So one of the tricks here is that you might be thinking, why do I need a course on visualization anyway? Can't I just build a scatter plot or a bar chart and I already know how to do that? Why is visualization design not a solved problem? Well, it turns out that visualization design in many cases is what we call a wicked design problem. It's multifaceted, it has lots of confounding factors, and in many cases we don't know yet what the right design technique to actually represent our data most effectively is. And this is why visualization design is an actual active area of research. We're learning about and developing new techniques for exploring and interacting with information every day. And to help see the variety of information and the variety of techniques that we have for choosing different visualizations and representing different data, I encourage you to take a look at this week's readings. So the first of these readings is called A Tour Through the Information Visualization Zoo. And this reading is going to give a survey of several less conventional techniques for representing data to give you a sense of just the sheer variety of data sets that are available out there. And the second reading is called Data Humanism. And Data Humanism is going to offer a less conventional perspective on the criticality of design in data science. So with that, I'd encourage you to check out those readings, and I look forward to seeing you in our next video lecture.